Hello, in this Verge3D tutorial we'll create an application with the effect of scroll animation. Here's what it's all about. When the user scrolls the page with the mouse wheel or scroll bar, it causes changes in the 3D scene. So basically the standard scroll feature of the browser controls what is happening with our object. At the same time, the text which is present in this page is scrolled as usual. This is a very interesting effect, which can be used for creating fancy websites, landing page or product presentations. So let's recreate this application. As a starting point, we'll use the Swiss Army knife application from the series Verge3D Basics. In the App Manager, open up the folder with this application. Simply copy and paste the application folder and rename it as Scroll Animation. Now let's delete all the files that we won't need in our new application. This includes textures from carbon and wood materials. Next, let's remove the compressed files for the exported scene. Also remove the files that relate to HTML-based UI, since we won't be using any buttons in our app. Okay, now let's rename the files of the application so that they are in correspondence with the name of the folder. But simply renaming all the files is not enough. We also must fix the links that exist between these files. So let's edit the .html file for our application. In this code, simply correct the links to the JS and CSS files. We must also edit the JS file itself in order to load the correct scene file, since it was also renamed. Here we replace Swiss Army knife with scroll animation. So this is it with the application files. Now let's open the Maya file and clean it up a bit. We won't be using the annotations, so let's delete all the objects to which they are assigned. Also, let's modify the camera for this application. In the camera settings, switch controls to disabled. This means that the user won't be able to change the view direction in the app. Instead, the camera will be controlled through scrolling. Now we are ready to export the scene. Get back to the App Manager, refresh the page so that our new application is displayed in the list. Let's run our application. The model is loaded, but the user cannot move the camera anymore. Now let's create a new scenario for interactivity. First of all, let's delete the puzzles that we won't need. The only puzzles we spare are the bloom puzzle and this group for anti-aliasing. We'll be dealing with this a bit later. So we are ready for adding new puzzles. First of all, we have to make a longer page so that we have something to scroll. This can be implemented either by editing the CSS code or by using the puzzle called setStyle. Here we select the property mean height. Let's add a text file for a new value. Also add the selector for the parts of the HTML page. Here we select body. Finally, we should specify some big amount of pixels to make the page longer and thus scrollable. Empirically, it was determined that for this application we need to set the length to 4350 pixels. Besides making the page longer, we also have to allow the browser's scroll bar to appear. Because right now it won't be shown even if the page is too long to fit in the browser tab. This can be done by setting the overflow y parameter to scroll. Let's save our puzzles and check it out. Now we have a longer page, as well as the vertical scroll bar to scroll this page. However, our 3D canvas is scrolled together with the page. To fix this, let's set the position parameter to fixed for the container element. This will make our 3D canvas, which resides inside the container, always stick at the same place. As a result, when the page is scrolled, the 3D canvas always stays visible. Now let's add animations to the 3D scene that will be caused by scrolling. In order to detect scrolling, we'll use another HTML puzzle called event. Here we select scroll. Let's add the element for which the scrolling will be detected. This should be window. The scroll value can be obtained using another puzzle called getAttribute. Here we select scroll Y, that is a vertical scroll. Here we'll also be using the window object. Let's quickly print the obtained value to the browser console just to see what values we are dealing with. Open the browser console with F12. Now if we scroll the page, we can see that the current scroll value is printed in the console. We'll be using these values in a moment. So, the first effect we want to create is the animation of folding and unfolding for our knife. First of all, let's create a variable to which we'll save the scroll value. Name it current scroll. Suppose when the user scrolls the page, the animation for unfolding the knife instruments should be played. In order to implement such a behavior, we should check the scroll value using the if puzzle, in which we add another slot else if. And we'll be comparing the scroll value with some limit. Say if scroll is less than 1000, the knife should be unfolding. Now the only thing left is to set the animation frame according to the scroll value. However, in Maya we only have 50 frames of unfolding animation, while the scroll value is changed from 0 to 1000. This means that we must map the scrolling range to animation range, so that the scroll value is converted to animation frame. Luckily, there is a pre-made procedure for that in the puzzles library. Drag out the respective calling puzzle for this procedure. Right-click on this puzzle and select inline inputs to make it more convenient to work with. Here, we should specify both scroll and animation ranges. As we suggested a moment ago, it starts from 0 and ends with 1000. Now let's add the animation range. Our animation in Maya starts from frame 0 and finishes with frame 50. Finally, we must insert the scroll value to the input slot of this procedure call. Now we can set the animation frame. This can be performed with the puzzle set animation frame. We also need another puzzle called Get Animations, because we have multiple animated objects that are saved in a group. Name it Animated Parts in Maya. So let's see how it works. If we scroll the page, the animation is actually played. It is also played in reverse, just like we want it to. Let's get back to the puzzles editor and copy and paste this group of puzzles. When the user continues scrolling beyond 1000 pixels, we want the knife to fold back. So let's specify the reverse animation range starting from frame 50 and ending with frame 0. Here we'll be checking our scroll value against two limits. It should be between 1000 and 2000 pixels. Let's see how it works. We can see that the knife is unfolded until scroll value reaches 1000 and then folded back beyond this value. So this is it with the knife animation. Now let's make the camera rotate around the model in accordance to scrolling. To do this, we should first animate our camera in Maya, and then use the same approach as with the knife model. Let's add a new camera by using the option Camera and Aim. Also add a circle to be used as the path for camera movement. So let's select the camera group and link it to the circle. For this, we'll be using the constraint Attach to Motion Path. In its parameters, make sure that the start and end time settings are set to 1 and 100 respectively. Click Attach. In the timeline, we'll also set 100 frames. Now the camera moves around our knife model. We, however, need to make it look at the model all the time. Select the aim shape. Now we want to attach it to the look at point object. This can be done using the constraint point. So now the camera is always looking at the model. Let's rotate our circle so that the starting position coincides with the position of the original camera. We can also deform our circle so that the camera moves up and down, thus producing a more interesting motion. There is one last thing we want to do. Select this group, go to Graph Editor and switch the animation curve to linear to make the camera evenly rotating. Okay, now let's bake this animation. Select the group, also select the camera. Go to the key menu and select Bake Simulation. We no longer need the circle, delete it. Also delete the constraint and the look at point object. The animation works perfectly. Also in the camera object settings, let's uncheck Auto Start in Animation panel. Do the same with the group. This is because we don't want the animation to play automatically. Now let's export to Verge3D. Refresh the puzzles editor to load the updated scene. Once again, add an if puzzle. This time we set the range between 1500 to 3000 of scrolled pixels. We want these two animations to overlap a bit, so that the camera starts moving while the knife is still folding. Duplicate this set animation frame puzzle. Here, however, we'll be using a list puzzle, since we've got two animated objects, including the camera, which is called camera 2, and the camera group. In fact, we disabled camera controls for the original camera, not for this one. So let's quickly fix this in Maya. To avoid confusion, delete the old camera. Now re-export to Verge3D. Be sure to refresh the editor after exporting. Let's copy the range limits to the inputs of this long puzzle. The animation range should correspond to what we used in Maya, that is from 0 to 100. This is it. Let's save the puzzles and check it out in the application. So the knife is first animated, unfolded and folded, and then the camera animation kicks in. It also works when we scroll in reverse. Now let's make the color of the knife change if the user keeps scrolling the page. To be able to do this, we should first modify the material in Maya. Temporarily hide the background sphere. Let's open up the hypershade. Remove the base color texture node, since we want to use mere color instead. We'll actually use two colors in order to reproduce this nice gradient. This can be implemented with a ramp node. Let's also add a blend colors node. Let's connect it with the ramp node and with the base color input of our material. So here we have two colors that we can use to paint our gradient. In order to be able to set the colors with the puzzles, let's add two nodes color constant. Let's name them color 1 and color 2 so that we can identify them in the puzzles editor later. Set the initial colors for these nodes. The first color will be lighter and the second will be from the darkest part of the image. So we basically reproduced the original image using just nodes. Let's delete the image node as we no longer need it. We should also restore the silver color for the logo. To do this, add another node, Blender Colors, and simply use the metalness texture as a mask for mixing. As a result, the logo has returned to its shiny look. The material is ready. We can now unhide the sphere and export the scene. Get back to the puzzles. We'll need two ranges, because we are going to change the colors once and then change them to another set of colors again as scrolling goes on. We'll begin changing the colors starting from the scroll value 2000. That is, when the knife animation is finished. We'll finish with the first set of colors at the scroll value 2600. Then we'll be twinning to the other set of colors starting from 2600 until 3200. The colors can be modified with the puzzle set color. Before proceeding, we have to save our puzzles and refresh the page, in order for the material to be updated with new color constant nodes that we just added in Maya. Add a material selector and select the name of our material, cover. As a result, the drop-down now provides two inputs for colors. For our convenience, let's switch this puzzle to external inputs. Now let's copy the map range puzzle and specify the scroll range as before. Make it from 2000 to 2600. Make copies for all three color channels, so that we can change the values for red, green and blue channels independently. The RGB values for the initial color can be copied from Maya. Let's copy the values from the red channel, from the green channel and from the blue channel. Let's do the same with the second color of our gradient. As a result, we have set the initial colors for both inputs of our material. So let's choose the target color for this scrolling stage. For example, we can make it a shade of red. Something like this. This color is good, so we can copy the RGB values to the puzzles. Let's see how it works. As we can see, the color is actually changed from blue to red. So let's implement twinning to the third set of colors. We can copy these two groups of puzzles. The starting colors will be the same that we finished with on the previous stage. This ensures a smooth transition to the third set of colors. Now let's choose new colors in Maya, for example, yellow, and copy the RGB values to the puzzles. The only thing left is to specify a new range for twinning to the third set of colors. Make it 2600 to 3200. Now we can check it out. First the color changes to red and then to yellow. Finally, let's restore the anti-aliasing feature so that it works with scrolling. Let's add a new variable, scroll_active. Initially, this variable should be set to false, meaning there is no scrolling. Once the scrolling begins, we should switch it to true. So we should allow it to render and switch the variable back to false after some short period of time. Let's use the timer puzzle for that. Rename it as scroll, set the period to 0.1 and the repeat setting to 1. Inside this timer puzzle, we'll change our variable to false. Also, in the beginning of the scroll event, we will remove this timer to prevent stocking them up. The only thing left is to check this variable every frame, so that the anti-aliasing is only turned on when the page is not scrolled, that is, when the static is static anyway. Let's see how it works. Indeed, when the user stops scrolling, the picture becomes visually sharper thanks to anti-aliasing. That's it with scrolling. In addition, you can add text blocks so that they are scrolled with the page. This can be done with standard web development means that we will not cover in this video. The result will surely impress your clients. Thanks for watching and see you next time.